Good morning, everybody, and very welcome to this webinar where we are going to discuss how the Seofoss can improve the biogas production. My name is Per Theilgaard. I am Technical Product Manager at Vilofoss, and I will take you through this session the next half hour. What we are going to discuss is the Seofoss, which is a slurry additive. It can be used for the biogas and also on farms. We will see how this product improve the flowability of the slurry. We will see how it affects the relationship between ammonia and ammonium. And these two aspects to actually improve the biogas production, and that is what we were going to see here the next half hour. Well, first I will introduce you to a measure of flowability. The flowability is actually measured by a term we call viscosity. And viscosity, that's a measure of the resistance of a liquid to flow, how easy flowable is a liquid. And just to give a few examples of that, we know water, it has a low viscosity as it has a low resistance to flow. So it's easily transported, and you can see when we empty the can, it's very fast poured out. So actually, there's a definition that this water have a viscosity on 1 centipose. On the right hand side, you see an example of a high viscosity liquid. It could be oil, it could be honey, or it could be a slurry with high viscosity. And as you see there, well, it takes time before it just empties the bottle, and even when it's coming up to on the table, it still stays together as a very creamy liquid, and it takes a long time before it actually disperses. These two examples, well, it have an effect on how much energy does it really need to transport this liquid, and you need more energy to move high viscosity liquid compared to a low viscosity. So it does affect how much you need to pump or how much you need to steer in the biogas, but it also affects a lot of other things. It does actually also affect the way the organism work in all this material we have in the liquid, and which is here in the slurry. So if we can lower the viscosity, we do increase the flowability of all the material. So we will have less material with sedimentate in the bottom, and we will also have less floating in the layer. And that's often the feed component you will have on the very top. And you'll see that we actually reaching a more homogeneous slurry in the biogas. And that is important because often we will see that many microorganisms, they will accumulate in the sediment layer, whereas the feedstuff in the very top. And if we need to have a high production, we need to make sure that the feedstuff and the microorganism, they have contact to each other. Otherwise, we will have a low efficiency. Another thing is that if you have a very high viscosity or you have a floating layer, well, then it's more difficult for the gas and the methane to get released, and that will reduce the production, and you'll have a lower efficiency. Just a common example of that on a photo here. That's here you have a picture of some slurry, and what you can see here, well, that's a gas in the bubbles here. And I think that you could kind of imagine then if it's a lot of resistance in this slurry, well, it's more difficult for this gas to reach to the top and get released, and when and then later capture it. And I also think that we can imagine that when we see these fibers, the straw, it could be some maize silage. We see the light green here. Well, it needs to have contact with all the microorganisms, so we can have a higher efficiency. So viscosity is important for the efficiency of the biogas. There's different way to measure that. Here on the left side, that's kind of a very traditional meter, what is often used in the labs. So you actually put the things down in the liquid, and then it's actually just measure the resistance, how to move around, to rotate. Another way to look at it is actually to look it as the time it takes before it's leave, in this example, in a funnel. That's also a method often used. And the more resistance there is in the liquid, of course, longer time it takes to reach the funnel. So here you actually measure the time, the seconds, before you can, it takes that this funnel is emptied. But here in the next data we will see it's all measured by this viscosity meter. We tested the effect of Seofoss, this slurry additive, on viscosity. We tested it on different biogas masses. First of all, on different components. We tested on biogas. It was tested on both 54 degrees and 37 degrees, two different temperatures. Also on the cattle slurry, it was tested on two different temperatures. That's what we have here in the middle. And then on the very right side, we have the pig slurry, which also was tested for viscosity on two different temperatures. And that was done at Aalborg University. Here we have the result for the swine manure. First of all, you can see have overall a very low viscosity around this 4 and 5, and the difference between the control and the Seofoss was about 20%. So Seofoss decreased the viscosity of the swine manure by 20%. Looking into the cow manure, first of all, we can see that the values now is much higher compared to the swine manure. We could also see that first of all we have an effect on the temperature. So on the 5 degrees Celsius test here, we are on around 3000 centipoles, and on the high 20 degrees Celsius, we have a much lower viscosity. And that's often, it's always like that when the temperature increase, well, then there is more movement in the whole material and the viscosity decrease. So it's nice to find it here also. But the effect on Seofoss was found to be 28 on the low temperature and 13 on the higher temperature. We also tested in some slurry from digesters, and again we saw a reduction at both temperature. At the 37 degrees Celsius, there was a reduction on 36%, and for the high temperature biogases masses, it was around 20%. And again, just the effect of the temperature is also obvious. So we can see from the control here, we are more than 1000 centipoles, and as soon as we go to a high temperature, with just under 10% of that. But a very high effect of Seofoss was found in all these tests we were making. We also investigated how long time it took before we were able to observe the differences, and actually the difference was observed in kind of immediately. So you can see here at here we have tested the viscosity in a period up to 4 months, and at all these test days there was a higher viscosity in the control values, which is the light blue, compared to the Seofoss values, which is the dark blue, already from day 1, and we can see that the difference is maintained all 4 months. And besides the effect of the Seofoss, though, we also can see there is a time effect where the viscosity is high here in the very top, and then it's just decreasing. And the reason for that is probably that over time, much of the fibers, much of the solid has been converted into gas, so there's now less solid in the material, and when there's less solid, then there's a lower viscosity. If you just look into the effect of on Seofoss, here we can see the percent-wise reduction. We can see that, well, that was kind of maintained here in the very start. It was about 20%, and that was also what we were able to observe here for 2 to 4 months. So the difference between the control and viscosity, that's kind of keeping on during all the time. The viscosity was also measured here at a different lab. Here we tested different masses. We tested some the feed waste, cattle slurry, swine slurry, and then the bedding material from poultry. And again, you can see that whatever material we are testing, well, we find a reduction in viscosity when Seofoss is added, and on average, that was about 15%, and that fit very well with the other results. So, just to summing up on this viscosity test, viscosity is when it's tested in the lab, well, it's a decrease about 20 to 30%, and it's maintained. The effect is maintained for a long period. We can also see that the solid have an impact on viscosity. So slurry from pig have a lower value compared with the cattle. And we also observed that there was effect on temperature on viscosity, so that higher temperature reduce the viscosity, makes it easier flowable. Yeah, so this will of course also affect the way the biomasses work in your biogas plant. The next thing we're going to discuss is ammonium and ammonia. And the thing is that ammonia will impair the biogas efficiency. The ammonia have a toxic effect on the microorganism. So if you have a high concentration of ammonia, well, you have a lower efficiency of your microorganism. And where ammonia is toxic, the ammonium is not toxic. So if we are able to change the equilibrium from ammonia to ammonium, well, we've also changed the environment for the microorganism. And we have made several tests on how Seofoss do change this equilibrium. Here was a test on different feed materials, as also shown earlier. And as you can see, we were able to increase the ammonium content in all these 4 different media, and on average it was around 7%. So 7% more ammonium were found after you have supplemented with Seofoss. And increasing the ammonium will decrease the ammonia, and that will increase the methane yield. And that's basically what we see here. Again, that was from a trial we made in vitro in Rostock. And you can see that the gas was increased about 3% when Seofoss was added. And if you're only looking into the methane, it was increased about 2%. So, it also demonstrates that there is this relationship between ammonium content and the methane, and also that when you have a lower viscosity, it would also, it by itself, improve the methane yield. But just summing up here on the ammonium, that the Seofoss, you are able to change the equilibrium between ammonia and ammonium. You get more ammonium. And the ammonia is decreased, and that means we have improved the condition for the microorganism, and we will get more methane output. The next thing that we were going to discuss is the results from plant tests. It was done at a place called stored biogas. We have a picture of it here. So that is placed here in the southern Denmark. And when we can see, they have the mixing and the controller room over here. They have the maize silage storage here, and the storage for slurry is one of these tanks. And after mixing, all the material is sent to the 2 digesters, digester 1, and then it's going to the 2 second digesters, where is following going to the last silo. At this plant, they have an upgrading system, so they are upgrading here the biogas, and then it's distributed in the pipes for the natural gas, which is spread around the countries. So the size of this place consists of these 2 times 4,500 cubic meter digesters, and the same size for the second digesters, and the storage here. And the way we performed the trial was that we started supplementing with the Seofoss with 20 grams per cubic meter, which was supplemented to the first 2 digesters here. So we calculated, first of all, the amount needed, 20 grams per cubic meter for these 9,000 cubic meter. That's a total of 180 kilogram, and that was distributed, supplemented through 3 days, 60 kilogram day 1, 60 kilogram day 4, and then again 60 kilogram day 7. After that, after startup, we continued the dosing of Seofoss. So we calculated the amount of Seofoss needed. Again, the recommendation is 20 grams per cubic meter was fed. And this quantity is then added twice a week through the mixer. Here we see the feed plan. The majority of the feed was slurry, deep bedding, olive, corn silage, heat-treated deep bedding, some glycerine. Yeah, and around 270 tons were supplemented to the digester tank each day. Here we see the results. On this graph here, we have both the realized output and the expected output. The expected output of methane was calculated from each of the components supplemented per day, multiplied by the expected value of this component. And the realized values, they came from the control system of the plant. So we can see here in the very start of the experiment, we actually have a lower performance of this plant. So we had 1,200 cubic meter less methane than we kind of expected. But after being using the Seofoss for the 4 months, we were able to change it to the opposite. So now we were actually performing a higher methane production compared to the expected values. A different way to present these data on is to look at it as an efficiency. So here we have the relationship between the realized and the predicted values. So here in the very start, the efficiency was about 90%, and after having used the Seofoss for these 3-4 months, we were able to change that to 105, 110%. So a very nice improvement of methane production. Here we see the supplementation and actually what happened is that the retention time it decreased due to an higher daily input. It started from about 255 and ended up on 275. So even we were the retention time was decreased in this period. The trial performed. We still have a better efficiency. We have a higher output from the same material in the system. We did also measure the ammonia content. We measured it just where the gas is leaving the digesters and going into the upgrading system. And it was measured with some drikkerør, as you see here on this picture. And the ammonia content was decreasing from the very start to the very end here of the experiment. It was only about 1/3 of the value here in the very end compared to the start. And lower ammonia is interesting, as it's, first of all, well, it's less corrosive, but respected to the methane production, we know that ammonia have a toxic effect on the microorganism. So this is one of the reasons that we get a better environment for the microorganism, and when the environment is better, they're performing better, and that's kind of also one of the explanation for the higher efficiency. The high efficiency is also kind of described in this table. Here we have values of the potential methane yield in the degassed slurry. That is the slurry going out from the plant. That was measured in the very start of the experiment, and it was also measured in the end of the experiment. And as you can see here, in the start of the experiment, there was still a high level of theoretical methane in the outgoing slurry that was decreased from 35 to 28. So, which is a 20% reduction, and that kind of also show how it's possible to get a high efficiency. This because this actually means that we have got more methane out of the same material. Here we looked into how the nitrogen is distributed. First of all, you can see that nitrogen in total has increased from the start of the experiment to the end of the experiment, and we can see that the form that we find it is in ammonia. So that has increased from 1.15 to 2.4. So we now have more of the nitrogen in the form of the ammonium and less in the ammonia. Again, that fits very well together. And as we will look a bit further into, is that this ammonium nitrogen also have a better fertilizing value for the plant. Here we have a picture of the plant manager, and what he also said, well, he was able to see the higher methane yield in his production system after he started up with a Seofoss. He also observed that it was easier to transport the slurry around, and it was more homogeneous. And he also observed that the top layer and the outgoing slurry now was less dense. So instead of it has a dense, small top layer, he said, well, it was less dense and it was more deep. So it is possible to see the effect of the Seofoss both on the different chemical analytical data we have shown, but also just the visual, the way the slurry react in the system. So the conclusion here from the test on the practical test is, well, first of all, we demonstrated a higher methane output. We found decreased ammonia. We find improved higher level of ammonia. So altogether, we improved the bacterial environment, which is, again, the overall effect of that is we have a high efficiency of the plant. Just a few slides on how this different nitrogen distribution have on the plants, and the effect of the Seofoss on the plant yield has been tested through 3 years in the official Seofoss tests. And if you do not know the Seofoss institution, I can tell, well, it's the Danish Farmers Advisory Service, which are doing this test. And the average of these 3 years tests is shown here in these tables. The interesting thing is they measured the yield, the kilogram nitrogen in the kernel per hectare harvested. And we can see that in the slurry where Seofoss was supplemented, we were able to find 3 kilograms more, which is around 3% more, a higher yield. They also measured the yield kilogram per ton per hectare, and here on average of these 3 years, they found that you'll get an extra yield on 140 kilogram of wheat, which is around 1.7%. So again, it's nice also to demonstrate that the measurement we find in the labs is also a measurement which do have effect on the field, on the plant, in the real world. Summing up, Seofoss decrease ammonia, increase the ammonium. That can be measured from the gas and from the liquid slurry. We saw that the viscosity was decreased, which means that we have increased the homogeneity and also velocity of the slurry in the tank. We have also seen that the residual methane in the manure, the slurry leaving the plant is less after if you're using the Seofoss. So overall, we can say that Seofoss improve the environment for the microorganism, and that's when the very end, which increase the efficiency of the whole plant. So now we are ready to take questions, and you're welcome to come with the questions here. You're also very welcome to send the questions later on by contacting Vilofoss or me. And there you can also find a lot more information about Seofoss on our Vilofoss homepage. But now you are very free to send us a question. Yeah, you can either open your microphone, or you're also very welcome to text it.
We have one question until now, Per.
Yeah.
Just read it up. Do you know how high the energy decrease for stirring is in a digester at 52 degrees when adding Seofoss?
Well, it's a very good question on how it changes the energy. I will not put any specific percentage on that, because it's really differ a lot to the different system. But I will say that all directions are going into, there's a higher flowability of the material. So if you are stirring, using the stirring, let's say as a fixed number of hours per day, well, you can expect that more material has been moved around. And then the next question could then be, well, can I then reduce the amount of stirring? And actually, you should be able to do that. Yeah, because then we know with the same amount of stirring, you will have a better stirring efficiency of it. But anyway, I think that in practice, most of the plant, they kind of continue with the program they used earlier, and then they will just see that more material is moving around.
Yes. Next questions. Have you made any assessments on economy in using Seofoss related to extra gas production?
Yes, we have actually tried to make some economic calculations, but the thing is that it really depends on the price of the methane you are getting. Our understanding is that it's a huge variation in the price on the market for that, because it's very high dependent on the subsidies giving in the individual countries. But anyway, I think that the specific plant, they can try to make a calculation which say, let's say we're getting 1% more higher outcome of the plant. That will be the what you're gaining, and then you can calculate the amount of Seofoss you need by saying how much material are we putting into the digester per day, and then multiply that with 20 grams. Then you can calculate the cost of using the Seofoss, and the difference between the higher outcome and the cost is a very simple way of getting an indication of how much you economically gain using Seofoss.
Yes. Next question. Why was the effect of Seofoss on ammonium and on the production of biogas negative?
What was that? Could you repeat that?
Why was the effect of Seofoss on ammonium and on the production of biogas negative?
Well, the Seofoss, in general, it was positive. We saw in basically all the tests that the ammonium content was higher. I think there was just one of the test, the one from Rostock, in one feed material, there was kind of the opposite, and I do not really know why it was entered like that. I think it was more like an error, because it is the material Seofoss is binding the ammonium. That is repeated so many times, and when it's binding the ammonium, well, you have less nitrogen for the ammonia, and so we see again and again that the ammonia content is decreased, and we believe that it's in totally, well, it gives this better environment for the microorganism, which give the higher yield of methane, helped by the better viscosity. So it's all small components, small balances. There's changed, which altogether give a high efficiency.
Will I spend all of the money made from extra gas production on Seofoss?
No, you will not. Well, I've not included a calculation here, but but you will often find an return of investment on 5 to 7. So you really get a high output compared to the extra cost.
Super. There are no more questions. Oh, just there's one popping up now here. can we make an assumption that the optimal performance of Seofoss we can see after 3 months?
The time period, well, I believe that it depends on the retention time we have in the system. In some system, they have just a retention time of around 30 days, and there's other having the retention time on 90 days. So I believe that we need to have the Seofoss distributed in the whole system. So the longer retention time you have, the longer time you should expect it takes before you see the effect. But as 3 months is a good point to look at. Yeah.
Okay. Now there are no more questions. Thank you very much, Per. It was really interesting to listen.
Very good. So we will then end the questions, and I'll just say thank you very much for participating in this webinar, and I'll just advocate for the next one. It's on the 24th of June. It's related to the pigs, and the topic is enteric health in pigs. Hope to see you at this webinar.
There is one more question for you to see.
If there's the question more is, if the Seofoss is added to pig slurry in the pig house, how much will the ammonia gas be predicted to reduce?
Well, was a good question. Besides using this Seofoss in the biogas, we also use it in in the staples for the pigs and also for the cattle. And we again, when we take a measurement of the manure, the slurry, we find an increased in ammonium in the liquid phase here as well. We have not made observations of the ammonia, but we have the response back that the smell is reducing, so that's also reflect a lower ammonia level. So you will be able to see the effect of the Seofoss in the biogas plant, but also without putting the slurry into the biogas in the pig and the cattle slurry itself, you will get the same effect.